On January the 9th, just days before the election, an unexpected incident occurred in Taiwan, where an alert was issued regarding a missile flying over the island and urged citizens to stay vigilant of an air raid. However, it turns out that the missile was actually the Einstein Probe satellite launched from the Xichang Satellite Launch Center. So what exactly is the Einstein Probe? And why was an island-wide alert issued? Hi, I'm Lisa, and this is Threshold in China. Following the surprising alert in Taiwan, let's explore the real story behind it. Launched on January 9th, the Einstein Probe is not just any satellite. It's a groundbreaking X-ray observatory developed through international collaboration between Chinese researchers, the European Space Agency, and Germany's Max Planck Institute for Extraterrestrial Physics. Weighing 1.45 tons, the observatory is positioned in orbit 600 kilometers, that is about 370 miles above the Earth's surface. It featured a wide-field X-ray telescope, constructed using innovative technologies that imitate the structure of the lobster-eye. This unique design enables the telescope to scan large areas of the sky and detect X-ray sources that were previously unknown. Additionally, the follow-up X-ray telescope will zoom in on the new X-ray sources or events, providing high-resolution observations throughout its 5-year operation. According to Yuan Weimin, the mission's chief scientist at the National Astronomical Observatories in Beijing, the probe's detection ability is more than 10 times higher than that of the similar telescope worldwide. Yuan explains that the probe can detect weaker and more distant signals, view them with greater clarity, and pinpoint their locations more accurately. Eric Koukos, the ESA's project scientist for the mission, expressed his excitement for the launch. He has been collaborating with the Chinese and German colleague on this project since 2018. Koukos stated that the probe's wide field of view allowed it to capture more bursts of X-rays than previous satellites. Now, observing X-ray in space poses significant challenges. X-ray is a form of electromagnetic radiation, and it provides valuable insight into high-energy processes occurring in the universe. However, many of these phenomena are transient and hard to detect, such as black hole tidal disruptions and collision of extremely dense objects. Moreover, soft X-rays emitted during the initial stages of these events are difficult to capture due to the Earth's atmosphere, which absorbs them. This is where the space-based observatories like the Einstein Probe become crucial. One other challenge is that the focusing soft X-rays through fraction or reflection is extremely challenging. Since the 1960s, more than 50 telescopes have been launched into the space to study cosmic X-ray. However, most of these telescopes have limited views. While some can quickly scan the sky, they could only see the brightest source. In 1980, Roger Angel from the University of Arizona developed a unique design for X-ray telescope that would have both a wide field of view and decent resolution. His inspiration came from crustaceans like lobsters and shrimp, which developed eyes with special structure to survive in murky environments underwater. A lobster eye has many tiny square-shaped tubes that converge towards a central spherical point. This structure allows light from all directions to reflect inside the tube and focus on the retina, giving the lobster an unlimited field of view. Angel's idea remained a challenge for a long time until recent years when microprocessing technology matured, making a technique called micropore optics possible. The wide-field X-ray telescope on the Einstein Probe consists of 12 modules, each containing over 13 million square micropores. Each pore measures 14 micrometers along the side and is coated with an ultra-thin iridium layer to enhance reflectivity. According to Yuan, the surface of these pores must be extremely flat and smooth with an error of less than 1 nanometer. It took his team a decade to develop the lobster-eye-like modules. For the first time, microporous lobster-eye technology has been extensively applied in a wide-field X-ray focusing imaging telescope, and this technology has been fully localized. Thanks to its design, the Einstein Probe can observe an area of the sky over 10,000 times larger than the size of a full moon at any given time. In contrast, existing large X-ray telescopes like NASA's Chandra X-ray Observatory can only image a section of the sky that is smaller than the size of a full moon. This means the Einstein Probe could observe almost the entire night sky in just 3 orbits around Earth, taking less than 5 hours. The probe's mission is multifaceted. It will systematically survey the sky, detecting X-rays from various cosmic objects including black holes, neutron stars, and supernovae. Of particular interest is its ability to detect dormant, supermassive black holes. These giants remain hidden until a nearby star drifts too close. When this happens, the black hole awakens, tearing the star apart and emitting X-rays that the Einstein Probe can detect. Another significant role of the Einstein Probe is its contribution to the search of gravitational waves. These ripples in space-time, predicted by Einstein's series of general relativity, are generated by events such as neutron-star collision. With its wide field of view, the probe is perfectly positioned to localize these events and observe their X-ray emissions, complementing ground-based gravitational wave detectors. Simply put, the Einstein Probe is a high-tech watchtower in space, giving us a new lens to observe and understand the most powerful events in the universe. It is a step towards answering fundamental questions about the nature of these extraordinary phenomena. And that is all for today's Threshold. We hope you like this new section on science and technology in China. As usual, we welcome your feedback and thoughts.